How do I move 2m? How do I get it onto the other side? Not a trick question. How do I get it off this side? And how do I cancel it out? By subtracting 2x. Now this side, all of these are like terms, so I can add them all together. So 3x plus 5x, 8x, and then I have my minus 2x gives us 6x. That's why we did unit 2. It's why we did collecting like terms, is actually to solve equations. What do I have left on the right-hand side? Plus 18, just the 18 hanging around. This step should look familiar because it's the last step of every equation we've done. How do we get rid of a coefficient of 6? Divide by 6. Does it divide evenly? X equals 3. Who got it on their own before I showed you? Awesome. How are we doing so far? Decent. I like decent. So take a look at 4, 5, 6. I grouped them together because you've got many, many fractions going on. So method when there is a bunch of fractions. One fraction, not so bad. We did those yesterday. That's where we just multiply to get rid of it. But when you have more than one, it's a little bit more hectic. Step number 1 is put each term over the lowest common denominator. Put each term over the lowest common denominator. Put each term over the lowest common denominator. Once we've done that, then we're going to multiply each term. Multiply each term by the lowest common denominator to cancel it. Multiply each term by the lowest common denominator to cancel it. After those two steps, it'll be a regular old equation like we're just used to solving. Okay, so let's look at number 4. So 2x plus 1 over 10 equals 3 over 5. And I'm just going to put the denominator of that 2x. We don't see it, but what do we know it is? 1. So imaginary 1 is there, just so we have our 3 denominators. Okay, lowest common denominator, 1, 5, and 10. What's the smallest number we can divide by 10, divide by 5, divide by 1? 10. Okay, so I'm going to put the first fraction over 10, second fraction over 10, last fraction on the right over 10. This is why we did Unit 1, which was all about fractions, was to be able to solve equations. Can you guess why we did Unit 3? To be able to solve equations. How do I change a 1 to a 10? What do I multiply by? 10, so 2x times 10 is 20x. What do I multiply 10 by to get 10? 1, so 1 times 1, 1. It means that second fraction didn't change. Not till we're done the examples. What do I change 5 into to get 10? 2, so 3 times 2, 6. There's step number 1, put each term over the lowest common denominator. This step is my favorite. What we're going to do now is multiply every single term by the lowest common denominator. So I just bracket them just to separate what the terms are. So I'm going to multiply the first by 10, the second by 10, and the third by 10. Can anyone see why we're doing this? Why are we multiplying by the lowest common denominator? Because it's going to cancel out. So what's the opposite of dividing by 10? Multiplying by 10. So what's left in that first fraction? Just the numerator, which is 20x. What's going to happen with the 10 and the 10 in the second fraction? Cancel out. So I'm going to be left with. And the last fraction, they're going to cancel, and I'm left with 6. So the purpose of those two steps was just to get rid of the fractions. So first thing, we put everything over the LCD, then we multiply it to cancel it out. This is just an equation from yesterday. This is a one-step equation. How do I get rid of a plus 1? Minus 1. So I have 20x on the left, and on the right, 6 minus 1, 5. This step should look so familiar because it's the last step of every equation. How do I get rid of the coefficient of 20? Divide by 20. Can I reduce 5 on 20? What can I reduce them both by? 5, so 5 divided by 5. 20 divided by 5. There's your final answer. Put every term over the LCD, multiply by the LCD, solve it as normal. Purpose of the first two steps was just to get rid of those fractions, so we didn't have to deal with them. Yeah, let's do another one with a bunch of fractions. M divided by 3 minus a half equals negative 7/4. What is the lowest number we can divide by 3 and divide by 2 and divide by 4? Offer of 12. Confirm. Okay, so first fraction over 12, second fraction over 12, third fraction over 12. Just turn to someone around you and fill in the 3 numerators. So turn and talk. I hear no talking. Nothing. Not even a little peep. What kind of learners need to turn and talk? Auditory. This is for the auditory learners. So even if you're not, help them out. Turn and talk. Okay, let's talk about the numerators. How do we go from 3 to 12? Perfect, so m times 4 is? Perfect. Who had that one? Good job. How do we turn a 2 into a 12? Times 6. 1 times 6? 6. Who had that one? High fives. How do we turn a 4 into a 12? Negative 7 times 3? Who had negative 21? High five to you guys. Step number 1, put them all over the LCD. Step number 2, you're going to cancel. How do we cancel? Multiply each term by 12. Again, I just put the brackets just to separate the terms, just so we know what's going on. This is a favorite part. Crossing them out is so good. 12 and 12 is gone. What's left? Just the 4m. Second fraction, 12 and 12 is gone. What's left? Kind of 6. Negative 6. And the last one, 12 is gone. What are we left with? Negative 21. What was the purpose of those first 2 steps? Why did we do them? Just to get rid of the fractions, because now we don't have fractions to deal with. Same steps like we did yesterday. How do we get rid of a negative 6? Plus 6. On the left, we have 4m. On the right, perfect, negative 15. This step should look so familiar now. We've probably done it 20 times. How do we get rid of a coefficient? Divide by 4, divide by 4. Can I divide evenly? Can we reduce? What do? We just keep it. We leave it. We're happy with that. Negative 15 on 4. Turn to someone in front. What is the lowest common denominator of 2, 4, and 8? 8. Perfect. How do we change a 2 into an 8? So n times 4. How do we change a 4 into an 8? So negative 3 times 2. How do we change an 8 into an 8? So 3 times 1. who had that step exactly the same. High fives. Step 2. Multiply everything by, for what purpose? The crossing out just makes me happy. I don't know why. I just love getting rid of those fractions. What's left in the first term? In the second term? And the last term? Who's got the same step where I'm at now? Good jobs. How do we get rid of a minus 6? On the right-hand side we have? How do we get rid of a coefficient? Can I divide evenly? Can I reduce? What do we do? Who had 9 on 4 is their answer? High five someone else with their hand up. I want to hear it. I want to hear it. I want to hear it. Good job, Cam. Good job. Why do we need to know this? What's the purpose? Well, it's actually true what the video said is you use algebra all the time. You just don't think about it. There's probably something every day you're like, I don't know that. Let's calculate it. So example number 7, just read to read. Don't overthink. Don't try to analyze. Just figure out what this is about. Then we'll start to pick out the key numbers. What's it about? A guy who's working and he's making money. Yep. Okay, let's pick it out. Do we care his name? Do we care where he works? Do we care he earns $400 a week? Oh, we care about that, okay. What else do we care about? 10% commission. Did anyone notice the word he is missing in that sentence? If he earned? Okay. How much were his sales? So at some point you might get a job with commission attached to it and you might have to figure out how much did you earn. What kind of jobs have commission? Retail, sometimes, depending on the store. What did I hear back there? I heard car sales is a big one that's on commission. Realtor, absolutely. So when you sell houses, it's on commission. What else? If you're an artist, you can be paid on commission. So how many paintings you sell, how many statues you sold. So lots of jobs in the real world are paid on commission. Okay, where do we start? Write down something. Yes, always a good place to start. What do we not know? How much were his sales? So let's assign a variable. What would you like to call it? S for sales. I like it. So the first step is we define the variable. Okay, what is S at sales? So I'm going to start my equation with an S. There's going to be an S somewhere in it. Let's build the equation around it. Okay, well, what about his sales? 10%. Well, how do I express a percentage as a decimal? Because we never have percentages in equations. We only have decimals. 0.1, put it over 100, right? So 0.10. So here's 10% of his sales. What number haven't we used yet, or what numbers? The 400, and there's a keyword we actually didn't highlight, and I'm going to grab my red pen because it's an important word, is plus. Why is that an important word?
You know it's addition.
You know it's addition. It's telling you plus how much? 400. And what do we know this is equal to? 635.24. That's just a regular old equation that we've been doing now for 4 classes. How do I get rid of 400? Minus 400. What's on the left? So what do I still have? 0.10 times S. And on the right? How do I get rid of a coefficient? I don't care if it's a decimal, I don't care if it's a fraction, I don't care what number it is, we're always going to divide. And this would be a calculator question. Some of you with good math skills may be able to do it without. So would it make sense that his sales would be $2.35? Okay, so probably the wrong way there with the decimal point. 2,352. Well, it's money, so I don't just want to do 0.4, I want to do 0.40 and then give me the units. There we go. Last one for today, just read to read. Oh, woo woo. $2,352.40. I hope he's not selling cars or he's not really a good car salesman. Oh, he's electronic, so it doesn't matter. The first time through, what do we know? What's it about? Money. Somebody bought something. Okay, second time through, let's start to pick out. Do we care his name? Do we care where he went? Do we care what he spent? Oh, okay, so what do you want to highlight? $8.25. Quarter of his allowance. Do we care what he bought? No. Well, I'm kind of concerned he spent $8 on candy, but whatever. Maybe he has diabetes. What weekly allowance? What do we not know? His allowance. A for allowance. So step one, we define the variable. Step two, we're going to build the equation around it. Find the word allowance and what's a number that's attached to it. A quarter. So how do I mathematically show a quarter? 0.25 if we want to do in decimal. If we want to do it in fraction, we could do 1/4. Which one would you prefer? Doesn't matter to me. Decimal, okay, so 0.25. What's the only number we haven't used? 825. Look at how easy that equation is. One-step equation. How do we get rid of a coefficient? Divide. Matthew, please don't throw things at your friends. Even? That's a pretty good allowance. I want to live with DJ. Don't forget the dollar sign.